Welcome back to Mthpt 103. We are moving on in chapter 5, and today we're going to be multiplying monomials. So a term that we need to make sure that we realize is a monomial. Mono means one. So what we're doing is we're multiplying single terms together. So we're just going to do some examples, and there's some exponent rules that we have to know. So on example 1, we're just finding the product, or we're multiplying two monomials together. When we do it, we only put together the like terms. So the plain numbers go together, so the negative 42 and the negative 0.5 get multiplied together. That gives us 21. Remember that a negative times a negative is a positive. Then we put the letters together that are the same letter. Now, the rule is when we are multiplying like bases, so in this case we have a to the first that we are multiplying with a to the third. So what this is really, if I think about it in its extended form, I have 1a times 3a's. And so when I look at those all together, I have 4 of them. So a to the first times a to the third is equal to a to the fourth. Now you may not want to write it out like this every time, so the shortcut is that you just add the exponents. So to get 4, I could just do 1 plus 3, and now I know that there are 4 a's. So this is a to the fourth. And then I have just a single b in the second term, so it's just going to carry over. So the final product of negative 42a times negative 0.5a cubed b is 21a to the fourth b. Now if you have more terms, it still is the same application. So we're going to put the like terms together. So the 5, the negative 17, and the 3 all get multiplied together. And that one I am not going to do in my head. So I'm just grabbing my calculator, which I should have already had out. But 5 times 17 times 3. So I have a positive times a negative, which is a negative, and then that negative times a positive is a negative. So I have a negative 255 for the number. I see in the first term I have an a to the first. The second term has an a to the second. The third term has an a to the third. So even though I have more than 2, I still do the same thing. So I'm going to add the 1 plus the 2 plus the 3. So 1 plus 2 is 3, 3 plus 3 is 6. So I end up with a to the sixth. And again, the last term is the only term with a b, so I just leave it as a b. If there were b's in all the terms or in 2 of the terms, I would do the same thing. I would add their exponents together. So that's what it looks like if you're adding a product. If you look at the ones in example 2, there's only, so I have a single term here. All of this inside here, there's no adding or subtracting, so it's a single term, it's a monomial. This time it's to a power, and so we treat those a little bit differently. I'm just going to do a little example over here on the side. So if I had x to the third and I squared that. So if I think about what squaring means, it's something times itself. So that would be x cubed times x cubed. Based on what we were doing up above in example 1, we already know we would add those exponents. So it would be 3 plus 3, which would give us x to the sixth. So if we want to look at these numbers and say, how can I work with the 3 and the 2 and still end up with the 6 without having to write it all out? Well, to do that, instead, if it's to a power, then what you end up doing is it's 3 times 2. Now this is if it's to a power. So we have a single term on the inside and a power on the outside. In those cases, we multiply. If I go back here to our original problem, every term has to be to the fourth power. That includes the numbers. So I have negative 4 to the fourth. I have an a squared to the fourth. a b cubed to the fourth, and a c to the fourth to the fourth. The negative 4 to the fourth, we would just grab our calculator and figure out what negative 4 to the fourth power is. So it's 256. And a negative multiplied 4 times. So a negative and a negative is a positive. That positive times a negative is a negative. Negative and a negative is a positive. If there's an even amount of negatives, it always turns positive. If there's an odd amount, it stays negative. So it's positive 256. Since I'm to a power, all of these exponents here are going to be multiplied together. So 2 times 4 gives me 8. 3 times 4 gives me 12. 4 times 4 gives me 16. So here's my final answer. I would be the same thing as if I wrote that term out 4 different times and did the product like I did in example 1. It would be the same answer. In example 2, on the B there, it has a product on the inside and then a power on the outside. So we'll go ahead and put together the inside, because we always do insides first, right? Order of operations. So since I'm multiplying, I'm going to add exponents. So that ends up with 2 plus 3 is 5. Now that is to a power, so since that is to a power, I'm going to multiply those on the outs, those two exponents. 5 times 2 is 10. So that's the answer. So they can be really big like in A, or they can be much smaller like in B. It just depends on the problem. In example 3, what they're wanting us to do is actually come up with an actual number. So we're going to end up plugging 2 and negative 3 in. You can do it right away, or you can find their product or their power and then go ahead and do it. So I'm going to combine the terms first and then plug in. It's a personal preference. When I combine these, there's just an invisible 1 in front of that A. So 9 times 1 is still 9. I have a to the first and a to the first. So 1 plus 1 gives me a to the second. And there's no other b, so it's b to the second. Now what I need to do is plug in the 2 and the negative 3. A is 2, and it asks me to square that. B is negative 3, and again, it's asking me to square that. So now I just do the numbers. So the math says to take 2 squared, which is 4. Negative 3 squared, which is 9. And then I'm going to take 9 times 4 times 9. And it's 324. So the number is the final answer. And so we're just working on the journey to get there. Go ahead and do the exponent first. So on each of these, remember that everything has to be to the second power. So the negative 2 goes to the second, the a goes to the second, and the b squared goes to the second. Negative 2 squared is 4. The a is, there's that invisible 1. So it's to the first power. So 1 times 2 is 2. 2 times 2 for the b's is 4. Now I'm going to plug in my numbers. It's the same numbers as above. A is 2. We're squaring it. B is negative 3. And we're doing that to the fourth power. I have 4 times 4 times, again, I have an even amount of negatives, so it's positive. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 4 times 4 is 16. 16 times 81. So this ends up being 1,296. So those are the 3 types of problems that you'll be practicing in section 5.4. If you have any questions as you go along your homework, make sure you send me a message either using Ask My Teacher or sending me a message through my email. Have a great day.